What's up, you freaking geniuses? So in this video, I'm going to teach you how to solve rational equations, all right? So you can basically break these down into 3 steps, all right? So first of all, you want to factor the denominators if that's possible, all right? Second step would be finding the LCD, which is the least common denominator or the lowest common denominator, all right? And then once you find that, you're going to multiply every single term or every single fraction by your LCD, okay? And then once you do that, some math and magic happens, because then you're able to cancel a bunch of crap out, and then it just turns into like a normal straight linear equation that's going to be a lot easier to solve, right? So let's start with this one right here, okay? So again, you want to factor the denominators if possible. And in this case, there's nothing to factor, so then we'll just go to step number 2. Find the LCD, all right? So let's do that. So what is the LCD in this case? Well, if you need some help on that, I'll link a video to that in the card above, but I'll kind of go over it quickly here. First of all, ignore the variables first. Let's just focus on the numbers. All right, so what's the LCD between 3 and 6? Well, that would be 6, right? Because 6 fits into 6 evenly, and 3 also fits into 6 evenly, right? So this is the smallest number that both of these numbers right here, both of these denominators fit into evenly, okay? Now let's look at the variables. So since we just have an x right here, that means we're just going to have an x right there. Okay, so the LCD is equal to 6x, all right? And then you just want to multiply every single term, again, by the LCD. And when you do that, you basically just multiply in the numerators. Okay, and now that we multiplied it, now we can start canceling some stuff out. Because if you notice, starting with this first one right here, we have an x on top and an x on the bottom. So those cancel out, right? So then on top, we're just left with 6 times 1, which is just 6, right? And then we're going to add that to this one right here. So here we have a 6 over 3, and we can reduce that down to a 2 over 1, right? So then on top, we're just left with 2x times 1, which is just equal to 2x. So we can write 2x right there. And then that's going to be equal to, we have a 6 on top and a 6 on the bottom. So those cancel out. So we're just left with x times 5, which is equal to 5x. Okay, so as you can see, now that we canceled a bunch of stuff out, it just turned into a straight linear equation, right? Which this is a lot easier to solve now. So to solve for x right here, let's get all the x's on the same side. So let's subtract 2x from both sides. Okay, so then here these 2x's cancel out, and we're just left with 6 is equal to 5 minus 2x, which is equal to 3x, right? And then to solve for x, all you have to do is divide by 3, right? And divide by 3. So then these 3's cancel out, so we're just left with x is equal to 6 divided by 3, which is equal to 2, right? So then this is your answer right here. X is equal to 2, right? Now the last thing we have to do is check for extraneous solutions. And an extraneous solution is just when your answer down here makes one of your denominators in the original problem up here equal 0, okay? So the only part we really have to check is this first fraction, right? Because this is the only one that has a variable, right? So it was 1 over x, okay? So if we plug in our answer right here for x, it would be 1 over 2, right? So did our denominator equal 0 when we plugged in our answer? No, it didn't, right? It's still just a 2. It's just a normal number. So that means this right here, x equal 2, is not an extraneous solution. It's just a normal, regular, good old-fashioned solution. All right, so here's our next example. 1 minus 5 over y is equal to negative 6 over y squared. Okay, so again, you want to start with step number 1, which is just factoring the denominators. All right, now here in the denominators, there's nothing to factor, okay? So then we can just move on to step number 2, which is finding the LCD, right? So let's do that. So what is the least common denominator between all these? Well, this one doesn't have a denominator, okay? So don't worry about that one. So let's just look at these two fractions right here. So here we have a y and a y squared, okay? So whenever you have two different variables, or I should say two different exponents, right? Same variable, both are y's, but they have different exponents. Just pick the one that has the bigger exponent, right? So that would be y squared, right? So then our LCD here would be y squared. Okay, so now that we've found our LCD, again, all we have to do is multiply every term by the LCDs. So now that we multiplied it, now we can start canceling stuff out. All right, so first of all, 1 times y squared, that's just equal to y squared. And then we're going to have minus this one right here. So on the bottom, we have just a single y, and on top, we have two y's, right? So then this single y on the bottom is going to cancel out or kill one of the y's on top. Okay, so then we'll just be left with one y on top, right? So then we're just left with 5y, right? 5 times y is just 5y. And then that's going to be equal to, here, this y squared is going to cancel out with this y squared on the bottom. So then we're just left with negative 6, right? So negative 6. Okay, so again, now we're just left with a straight linear equation, right? Y squared minus 5y is equal to negative 6. And it almost looks like a quadratic, right? But the only difference is we'd have to move this negative 6 basically to that side right there. Okay, so let's do that. So let's rewrite this as y squared minus 5y. And then here, this negative 6, we're going to add 6. And what you do to one side, you do to the other, right? So we're going to add 6 right there also. So we're going to have plus 6, okay? And then here, negative 6 plus 6, that just goes to 0, right? So then we're going to set this equal to 0. Okay, so now we're left with y squared minus 5y plus 6 is equal to 0, okay? Now, in order to solve this linear equation, we're going to have to factor this, right? Because it's a quadratic, so we can factor it. And the way you do that is, well, this has a leading coefficient of 1, right? So we can factor it by putting it in two sets of parentheses like that. So this y squared, we can split it up into y times y. And then to figure out the numbers that go right there, just look at your last number right here, which is a positive 6, right? So what two numbers can I multiply together to get positive 6, but they also have to add up to the middle number, negative 5? Well, in this case, it would be a negative 2 and a negative 3, right? So those are the numbers that go right here. So minus 2, minus 3. Okay, and again, it's still equal to 0. So still set that equal to 0. Okay, now that we have two sets of parentheses and two y's, that means we're going to have two solutions, okay? And the way that you solve for each of these is basically just set each of your parentheses equal to 0, okay? So if we want this parenthesis equal to 0, y would have to be equal to 2. And inside of these, y would have to be equal to 3, okay? So then these are our two solutions. Y is equal to 2 and y is equal to 3. Now the last thing we have to do is just check for extraneous solutions, right? So let's take y is equal to 2 and plug it into our denominators. So if we plug in a 2 right here for y, well, is that going to make the denominator equal 0? No, it's just going to be equal to 2, right? And if we plug in a 2 into this denominator over here, y squared, well, then we would just have 2 squared, and 2 squared is equal to 4, right? Is there any issue with that? No. Okay, so then y equals 2 is totally fine. That's a solution. Now let's check y is equal to 3. Well, again, if we plug in a 3 into the denominator over here, there's no issue, right? It doesn't equal 0. And if we plug in a 3 into this denominator over here, well, 3 squared would just be equal to 9. And again, there's no problem right there, right? So y equals 3 is totally fine also. Okay, so then y equals 2 and y equals 3 are both solutions. Okay, so here we have 5 over 3u minus 2 is equal to 3 over 2u, right? Now, whenever you basically just have like two fractions equal to each other, one way that you can always solve these is by cross multiplying, right? So that's what we're going to do here, right? So first of all, let's multiply these two together. So 5 times 2u, okay? 5 times 2u, and then you just set that equal to your other cross, okay? So 3 times 3u minus 2. So 3 times 3u minus 2, okay? So now we can simplify these, right? So 5 times 2u, that's going to be equal to 10u, right? 5 times 2 is 10, and then you just have the u tacked on right there. And then here we're going to have to distribute. So 3 times 3u, well, 3 times 3, that's equal to 9, and then we have the u right there. And then 3 times negative 2 is equal to -6 or -6, okay? And then remember, these are equal to each other. Now, again, we're trying to solve for u, right? So let's try and get the u's all on one side. So I'm gonna move this u, this 9u, to that side. So we're gonna do that by subtracting 9u and subtracting 9u, all right? So then these 9u's cancel out, and we're just left with -6 on this side. And then that's equal to 10u minus 9u, which is equal to 1u, or essentially just u, right? So then your answer right here would be u is equal to -6. All right, now again, all you want to do is take your solution and plug it into your denominators and make sure you don't get a 0, okay? Because if you do get a 0, that means it's an extraneous solution, right? So first of all, let's plug it into this denominator right here. Let's write it off to the side. 3u minus 2, okay? So if we plug in our answer, -6 for u right here, well then this will be 3 times -6 minus 2, and that's equal to 3 times -6 is -18, and then this minus 2. So -18 minus 2, that's equal to -20, okay? So when we plug in a -6 into this denominator, we get -20, which is totally fine, right? We just don't want a 0. And same thing with this denominator right here, right? 2u, got to plug it in there. So we'd have 2 times -6. So 2 times -6 is equal to -12, right? So again, not a 0, so that's totally fine. All right, so then this is just a regular solution. U is equal to -6. Okay, so here is our next example. Okay, so again, the first thing you want to do is factor the denominators if possible. And in this case, we actually can. And specifically this one right here, the p squared minus 4. Because if you notice, this is actually a difference of squares, okay? If you don't know how to factor a difference of squares, I'll link a video to that in the card above. But basically all you do is, well, first you need to recognize that both of these are perfect squares, right? P squared and 4. Okay, so you just take the square root of each of them. So the square root of p squared, that would just be p. And the square root of 4 is just 2, right? So then in order to factor this, it would simply be, taking these two right here, you would just do p plus 2 and p minus 2. Okay, you basically add them together in one set of parentheses and then subtract them in another one, okay? So I'm going to rewrite p squared minus 4 as this factored answer right here, p plus 2, p minus 2. Okay, so if we factor again this denominator, it would turn into p plus 2, p minus 2. Okay, cool. So we factored the denominators. Now let's move on to our second step, finding the LCD. Okay, so then the LCD in this case, well, in this case, we don't have any numbers really by themselves, right? We just have a bunch of expressions, okay? So then all you have to do is multiply all the expressions together, okay? But if you have similar ones, you don't have to write it more than one time. So for example, we have a p plus 2 here and a p plus 2 here, okay? But I'm only gonna write it once. I don't have to write it down a bunch of times. Just write it down once. And then what else do we have? We also have this p minus 2 here and a p minus 2 here. So again, I have multiple, I have more than one, but I'm only gonna write it down once, okay? So then the LCD would just be p plus 2 times p minus 2, okay? So since we found the LCD, again, all we have to do is multiply all the numerators by the LCD, right? Okay, so now that we multiplied all the numerators by our LCD, again, math and magic, right? We get to cancel stuff out, all right? So up here, we have a p plus 2, and down here, we have a p plus 2, so those cancel out, okay? So then we're just left with 2 times p minus 2 on top, right? So let's write that down. 2 times p minus 2 on top, right? And then we're going to add that to this one right here. So again, cancel stuff out first. We have a p minus 2 on top and the bottom. So we're just left with 4 times p plus 2 on top, right? So 4 times p plus 2 on top. And then that's equal to, we have a p plus 2, p minus 2 on top, and we have the exact same thing on the bottom. Okay, so these are all going to cancel out, and we're just left with this p minus 1 right there. P minus 1. So first, let's simplify everything. In order to do that, let's distribute first. So let's distribute this 2 into this set of parentheses right here. So 2 times p, that's equal to 2p. And 2 times negative 2, that's equal to negative 4. All right, and then we're going to have 4 times p, so that's positive, right, because plus 4p right there. And then 4 times 2, that's equal to positive 8. And then that's equal to p minus 1, right? Now let's simplify some things. So first of all, we have a 2p there and a 4p right there. So 2p plus 4p, that's equal to 6p. And then we have a negative 4 and a positive 8, right? So then negative 4 plus 8, that's equal to positive 4, right? So plus 4. And then that's equal to, again, p minus 1. Okay, now we're solving for p, right? So we want to get all the p's on the same side. So here, let's subtract by p right there and subtract by p right here. And with the numbers, let's move the numbers to the other side. So here we'll subtract 4, and here we'll subtract 4. Okay, so those are going to cancel out, and those are going to cancel out, right? So on this side, we're left with 6p minus p, which that's equal to 5p. And then that's equal to, right, equal to this right here, negative 1 minus 4, which is equal to negative 5. All right, so then to solve for p, just divide by 5 on both sides. Okay, so then these 5's cancel out, and we're just left with p is equal to negative 5 divided by 5, which is equal to negative 1. All right, so then that's your answer right there. P is equal to negative 1. Okay, and the last thing you want to do is just plug in your answer into your denominators, right, to make sure you don't get any zeros in the bottom, because if you get a 0, that's called an extraneous solution, right? And I'll leave that up to you on this one, but you'll find that you don't get a 0 in any of the denominators when you plug in a negative 1, okay? So p equals negative 1 is just a regular solution. So if you found the video helpful, definitely leave a thumbs up down below. And if you have any other questions or want to see any other examples, just let me know in the comment section below. Also, there's a couple playlists attached that I think you'll find helpful, so definitely check those out, and I'll see you there.